Very good morning to all of you, and really thank you for joining today's webinar by sparing some of your valuable time. As you can see from the theme of this webinar, GeoAI or AI in GIS is impacting many of the projects that government is currently carrying out. Encroachment detection is one of them. Different government department in urban, land and forest domain in last 5 to 6 years has been working on land encroachment utilizing AI and high resolution imagery. So in the next 50 minutes, my colleagues will showcase how the GeoAI is helping the government address some of the pressing issues, which currently we are facing across various urban and other sectors on the encroachment, and how government authorities can leverage the automated system enhanced by AI. I would also like to mention that periodic satellite or drone data and GPU processing plays a crucial role here. Thus, we have seen sometimes our customer don't have the required IT infrastructure to run these models. Our cloud managed team will showcase how the Esri India Cloud Managed Service can help you in respect of to managing your IT infrastructure to handle this kind of projects. I'm joined by my colleague Sarana, who leads the AI initiative for Esri India, Ashish, who was the project manager of one of the customers, and Vedika, who is from our cloud managed service team. Over to you, Saranya.
Thank you, Deepak. So the field of AI is advancing rapidly with the invent of neural network-based models, which we call as deep learning models, computer vision, generative AI, LLMs. This field is rapidly advancing. And in this session, we will discuss about how we can use these models for our geospatial problems. So GeoAI is actually at the intersection of models that can be used for computer vision, NLP, and use them for GIS and imagery based data. And AI is not new in ArcGIS. We have been using machine learning since 2008 in geospatial machine learning models like regression models. And we started our R&D in early 2017. And in 2020, we released our first pre-trained AI model. These models are ready to use models which you can download and use it. And from there, as the field of AI progresses, the same advancement have been integrated within our GIS ecosystem. So our users can take advantage of these technologies and use it in their workflows. And currently we have been integrating LLMs and really big models like SAM, TextSAM, which are really good vision language foundation models. So you can think of AI capabilities in ArcGIS into two different themes. One is GeoAI, where we are incorporating these AI algorithms to automate data extraction at scale and uncover insights. And another aspect of it is improving your experience of ArcGIS using AI assistants to boost productivity and help you with your everyday workflows. Now we'll focus more on the GeoAI. So GeoAI, what can be done with GeoAI? So you can extract data. So the first aspect of GeoAI is it can work on multiple modalities. It can work on imagery data sets, 3D data, or even video feeds. It can also work on unstructured text data where you can use NLP or natural language processing. And when we talk about another aspect, it is analyzing data where you can use machine learning and deep learning models to analyze vector data, tabular data, and time series data. When we talk about extracting spatial data, most of you might be familiar with feature extraction from imageries, but it is not limited to just imageries. You can have models that work on 3D scenes, motion imagery, which could be your videos or full motion videos. There are models that work on point clouds, overhead imagery. It can be from satellite imagery or drone imagery. And it is not necessary that you should always use RGB. There are models that can be trained for multispectral imagery, SAR, or any other types of images as well. And if you're collecting field data using mobile phones, or you're having 360 panorama survey of your study area, those images can also be incorporated. And Esri is releasing tools that can help you with every step of the way. So you can think of ArcGIS as an end-to-end GeoAI system where we provide all the necessary tools from data access to running inferencing. So once you have captured your images, how do you catalog them? How do you access them? And how do you prepare the data? Tools to train the model, tools to deploy the models so that it can reach multiple stakeholders. How can they consume model? And how can you scale it up, whether for a city level or a state level? You have tools available in ArcGIS for this end-to-end. So we do provide APIs that can extend these capabilities. We do have GIS tools that leverage these AI capabilities. We provide pre-trained models that are trained on large volumes of data set. And we also provide apps and solutions that are powered by GeoAI. And what you're looking on your screen right now is a list of some of the pre-trained models that have been released recently. Some of the important ones is Segment Anything model, which is released by Meta. Next one is TextSam, which accepts free text as an input and helps you with the feature extraction. And we are seeing with the invent of LLMs, there are a lot of interest in integrating these language models with GIS. So prompt-based segmentation and vision language models are examples of those. And we have also released a building footprint extraction model for India. So we have trained it on a 10 to 50 centimeter imagery sourced within Indian geography, and we have trained it with Indian data sets. I encourage you all to take a look at this page and download this model, try it, and do share your feedback. And when we talk about building footprint extraction, it could have multiple facets. For example, in rural area, buildings are usually dispersed, and the challenge is the model should be able to pick up even the isolated buildings that are present. The challenge in semi-urban area could be you have buildings of different sizes in close proximity. You can have really large buildings and really small buildings in the same area. In urban, the challenge is about contiguous buildings. The buildings are very congested. It can be a challenge to delineate one building from another. And as we move from a flat terrain to undulating terrain, different challenges emerge. And in India, we also have the issue of informal settlements. So a model needs to work on different areas, and it is essential to understand this variance we have in our country. And AI, you can also create your own AI models for extracting not only buildings, but also other features like field boundaries or road extraction as well. Now I'll move to my browser to show you how you can access these pre-trained models. So you can browse to livingatlas.arcgis.com, and there in the search window, just type DLPK. It will automatically guide you to this model page. And you can see currently there are over 94 models. And this is for multiple features, like you have models for road extraction, building footprint extraction, land cover classification, etc. So let us say that you are interested in any of this model. You can click the model and the model page will give you all the necessary information. For example, this road extraction model is used to extract roads from high resolution aerial or satellite imagery. It also gives you information about what was the input used. So here it was a 8-bit 3-band 1 meter imagery. And the geographies it is expected to work. You will also have information about what was the model architecture used, what were the accuracy metrics, and some of the sample result. So this is what we call a model card page, which gives you a qualitative and quantitative assessment of the model. And each model has its own guide page, which guides you with a step-by-step instruction of which tool to use, where to find them, what are all the right defaults. You will need all the necessary information to help you get started in this Use the Model page. So that was about how you can search for DLPKs, how you can find the model you want, and how to start using them. Let us take a look at some of these models and see a demonstration. The first one I would like to show is Segment Anything model. So this was released by Meta, and it is one of the largest model. It is trained on 1 billion mask data set, which has a diverse set of 11 million images. And it is very good at segmenting anything in an imagery. So this can be a good foundation model for your workflow. Let us move to ArcGIS Pro and take a look at one of the example. So you can find these tools in Image Analyst Toolbox. So first I will apply SAM model on this place. So I have an input imagery on in Andhra Pradesh. It's a Mangalagiri region. So to use SAM, you can use detect objects using deep learning tool, point to the input raster and load your model definition file. And since this model is GPU intensive, you can call the GPU and the right GPU ID and start the tool. And SAM gives you an output like this, which segments everything in an imagery. So this is what SAM is good at. But if you're interested only in the buildings or only in the building footprints, you can use a model called Text SAM, which is a combination of SAM and another model called Grounding Dino. So the USP of Text SAM is here you can give text prompts in simple English. You can explain what is the object that you're interested in. And it also accepts multiple keywords. So here I can say tin, gray, roof, rooftop, shelter, house, building structure to explain the object I'm trying to extract. And this will give us focused detections. So instead of delineating trees and other segments, it is extracting only the building footprints. So that was about SAM and how you can use text SAM. Next, I would like to show you a demonstration of building footprint extraction model for India. So let us move to Nagpur. So here I have a 3-band imagery of Nagpur city. And to use this model, you can use classify pixels using deep learning and call the corresponding model definition file. And you will get a raster as an output here. And you can apply post-processing techniques to automatically convert these raster to polygons. And don't worry, we have shared a very detailed guide page here, which will again work you like it will give you a step-by-step instruction on what are all the post-processing steps, what are all the good defaults, where the model is expected to work. This guide page is also available for download. So that was about our building footprint extraction in India. Just to show you how the model behaves in other geographies as well. So we are in a hilly terrain in J&K. So this is how the model has performed. Since this is a hilly terrain, let us move to a 3D perspective so that we can appreciate how well the model has performed here. So you can see that in spite of the undulating terrain, the model is able to pick up even the isolated of the buildings. So that is why models like this can help us reduce a lot of manual effort we put in manually digitizing these buildings. Let us move to another location now. So here we are in Kerala. It's in northern part of Delhi. So challenge here is slightly different. So till now we saw buildings that were decently separated. But here the buildings are very congested. It is very difficult for me to even see the narrow lanes that exist between these building clusters. So this is when supplementing your RGB with another data set can help. So when I added the DSM, I could see that I was able to delineate the foreground from the background. Adding this height dimension has helped me understand where the lanes are and how one building is different from another based on the heights. So I had created a composite which includes the DSM as well. So when you add supplement data like this, you can see the model performance improves. But this is SAM, so you do see there are some false positives like cars that have been detected. Since SAM is good at detecting everything, you can apply filters based on area to remove such false detections. And with ArcGIS Pro 3.5, also have a tool called Extract LOD2 Buildings, which accepts DSM as one of the input and building footprint as another input, and automatically gives you 3D buildings of the same area. So if you have already run 3D, sorry, if you have already run the building footprint extraction for this area of interest, you can use them as an input to generate 3D building footprints as well. Chances are you are a GIS analyst and you are working on multiple features at the same time. You're not working just with building footprints, you also have other features like roads, trees, etc. What about those cases? Do you have to run inferencing one by one? Not necessarily. GS Pro also offers you a tool called Extract Features using AI models, which lets you select multiple models at the same time. For example, here I'm selecting land cover, road extraction, and canopy height model. And if you have trained your own model and have any local copy of your DLPK, you can call that as well. So what this model does it also has intelligent post-processing options in case you want to do like regularization of your polygons or regularization of your lines. Those inferencing options can also be added here. And the output of this is usually a group layer which has all the outputs that are generated. So in this case, I have my land cover, tree height from canopy height model, building footprints, roads, everything generated in one go. And it also offers you an information summary, which gives you a table of what are all the outputs that are generated, as well as the location of these outputs. So if you have to run multiple models at the same time, you can use this tool. And in some cases, you only need to fine tune your post processing. In that case, you can run only post process at the same time. And another use case of AI is to do encroachment studies or to understand what are all the changes that have happened in an area of interest, right? So for this, we will need two images from two different time periods. So here we have trained a model to detect only the changes that have come up. So traditionally, when you do pixel to pixel based change detection, all the changes that has happened in an area will be highlighted. Like it could be trees, or there is a car or a parking area with lot of cars. Even those changes gets picked up. But with AI, you can train a focused change detection model that only highlights the area where new buildings have come up. I'll show you another example of the same model in Hazira. So this here we have a mixed land use where we have both industrial buildings and residential buildings. And I have a before imagery and after imagery. So using the feature extraction capabilities and AI capabilities, you can train a model which will highlight only the locations where new buildings have come up. So to summarize, we saw how you can use models like SAM, text SAM, how you can have your own models, how you can access the pre-trained models, and how you can leverage the existing models in your workflows. Now I will hand over the session to my colleague Ashish Pal, who will discuss in detail about one of the case study. Over to you, Ashish sir.
Thank you, Saranya. Good morning to all the presenters, and good morning to all the participants. Myself, Ashish, I will take you through the UK GAMS solution, which is an implementation of the GeoAI, which my colleague Saranya has told. Let me share my screen. So I hope my screen is visible. So and this is Uttarakhand Government Asset Management System. It is hosted live in the production environment of Uttarakhand Space Application Center. And this is the URL for this application, http://ukgams.uk.gov.in. This is a public landing page, and all of us can visit and see the details of this solution here. Now, before going into the technical nitty-gritties, the good news first. So the impact of this initiative after rollout in Uttarakhand. So within a record period, almost 75 to 80% of the total government assets have been geotagged, geofenced, or polygonized. So as the number says, for data collection, 66,000 government assets mapped in the system, and out of those, around 55,000 or 52,000 assets have been geofenced and polygonized. These data, once collected, subjected to change detection, has enabled the government of Uttarakhand to monitor around 14,000 crores of government assets across Uttarakhand state. Since the rollout and implementation, the encroachments worth rupees 53,000 have been 53 crore has been detected through this system. There are 188 alerts which are ongoing on the ground as on the date for 2 of the high priority area districts. There is coordination between 60 plus departments. There are many directorates involved, also various authorities across all the 13 districts of Uttarakhand for seamlessly validating the changes which are being verified real time on the ground. All of this has been reported in a proper structure, automated fashion, and is ultimately helping the government to monitor their land and monitor these assets, and ultimately helping the citizens of Uttarakhand for proper infrastructure development and facilitation. So with the efforts of the custodian of this solution, which is USAC, and the efforts of Director USAC, I enjoy pride to say that this project has been a milestone for Government of Uttarakhand in achieving Prime Minister's Award for Excellence in Public Administration for the year 2024 in the innovation category. This project has been a milestone in multiple ways, and now let me introduce the details of this project. So what is the UKGAMS system? The system is basically a digital solution which helps end-to-end AI/ML-based encroachment detection using satellite imagery of very high resolution. This system enables the government to safeguard and monitor their lands and assets, and essentially to prevent the encroachments up to the extent possible. This system helps real-time verification and validation of all the notifications or all the alerts, which helps ultimately ensure timely interventions. Also, along with the AI/ML thing, this solution has brought completely digitized workflows, which were manual till now, and this has promoted operational efficiency and the transparency of the system as such. So let us take a quick look at what this system does. So as I mentioned in the initial milestones of the impact, these are the objectives of this solution. So data collection is the first and foremost objective, using the very high satellite imagery, very high resolution satellite imagery. We have enabled the solution through a mobile application for collecting the data on the ground for its validation and verification also. Now, once the data is collected, the system then subjects this data to change detection, and particularly the built-up area changes are detected using AI/ML technology. Periodically procured VHR satellite imageries are used for this. Now, once the changes are detected, the system floats these change alerts as notifications to the corresponding users or the owners of these assets. These alerts, once they reach the owner of the asset, are further allocated and assigned to the field workers or the surveyors, where the geotagging happens and the verification of the alert happens using various photographs and videos and other methodologies. This is a editor approver workflow which ensures all the data which comes to the database is sacrosanct or high integrity. Once all this information is validated and verified on the ground, the correct and scientific data comes back to all the stakeholders and all the officials involved in this initiative in the government of Uttarakhand, and is disseminated through various decision support systems like GIS reports and dashboards. This system also ultimately helps the government to share data on a large scale with other departments and other users through curated data analytics. And ultimately, all the urban and government departments are the beneficiaries of this shared information for decision-making purposes. I will take not much time, but I'll show you some glimpse of the videos that are captured live from this solution. And it is hosted in State Data Center of Uttarakhand. So this is the landing page of this solution, which I told you in the initial slide, ukgams.uk.gov.in. It has all the information about this project, the lineage of this project, and what all our components are. Now let us enter into the system. This is a custom user login, and there is extensive levels and types of users who are using. Once we enter, there are 4 modules: user management, map application, dashboard, and MIS reports. All of these are presentation methodologies of the data captured. Now let us have a quick look at the WebGIS application. So you can see this is the map application, and it is showing you the Uttarakhand state map. All this is procured proprietary data of Uttarakhand Space Application Center. Here we are seeing how the system shows a particular set of facilities in the form of tools for change detection. So for a particular district or across the state, you can select the source imageries and the target imageries on which you want to perform the change detection. All the imageries available or procured till date are available in the system for any many-to-many comparison. Once you trigger the change detection, this technology architecture follows, where there are multiple servers engaging with each other, starting from the web server from where the request goes to the ArcGIS server, Esri ArcGIS platform. And this server takes the Python scripts and geoprocessing service to the GPU. GPU is the mind of this whole solution, where the processing happens on change detection, and a detailed report of all the changes captured in the particular cycle are generated. This is all automatically generated report. No manual curation is required here. All the archived reports generated till date are also facilitated through this system. You can have date-wise chronologically ordered reports. This is one of the sample reports where we can see for a district of Uttarakhand how the information is presented. All the asset information, which is the data collected, along with the changes detected department-wise and the changes detected district-wise, are forming the front side of the report. And then we follow this report through various annexures. Each of this page that you are seeing right now gives you the information about the asset and the change which is detected in the form of area and percentages. Coming back, we can see once the alerts are floated into the system from the GPU, how you can view them. So you are selecting a particular district here, or you can select all of them together, and the system shows you all the alerts for the particular district and of the duration. You can click on any of the assets here to view the information of that particular asset. It will take you there and will show you in real time what the system has identified. So here the purple color boundary is the asset boundary marked by the department, whereas the cyan boundary is the change identified by the AI engine. Now, in order to validate whether this is correct information or not, the nodal agencies can use various analytical features in the solution itself, like swipe or overlay, where you can compare imagery to imagery and see whether the change seems genuine or maybe a noise. This is all automated, no manual intervention here. So you can see on the left, the base map imagery, and on the right, newly procured imagery. And you can see clearly a new building has popped up. It seems to be a tin shaded rooftop. These features enable the decision makers to take strict action or take this system information further into the solution. Because until you validate a particular change, any verification validation activity seems meaningless. Now, once analyzed, you can mark it as genuine or noise as a nodal agency. Once it is marked as genuine, it flows into the mobile app. Once the mobile app users receive this notification, you can see a supervisor dashboard here, where the supervisor has received certain information belonging to his asset or her asset. And now this alert information needs to be passed on to somebody who can survey on the ground in the real time and verify whether the change alerted by the system makes any genuine sense or not. So here the supervisor is assigning it to Ms. Tanuja Bora, who seems to be a surveyor here, with their remarks on verification purpose. So once it is assigned to a field user or a surveyor, this is how the dashboard of a surveyor looks. You can see they have received one change recently, and this change, once clicked upon, this is all in the mobile application. You will land on the map and you are redirected to that particular asset on top of which you clicked. This helps the user not to navigate or not to explore. So this is the asset information. Asset information is coming from legacy database as well as during the polygonization or the geofencing capture. So you can see on the ground, the user is filling the encroachment information and all the details of any suspected encroachment on the ground. After filling all this information, we have provisioned capturing of photographs and videos. So here you can see the surveyor is capturing some photographs from various angles to ascertain the encroachment here. So the system facilitates 3 photographs and 1 video, and all this is stored in the archives of the system. This information is persistent in the database, so at any point of time it can be referred to. And all of these is being done by a simple Android mobile device. Once this information or evidences are captured in the system, it is submitted for further verification. And once these verification evidences are validated by the supervisor through a approval workflow, they come back into the database, and then there are various presentation formats like dashboards and reports, which inform this to the recipients of the information. To summarize, I will show you a quick video which is also available on the public landing page.
Welcome to the map application of the Uttarakhand Government Asset Management System. Here, you can visualize and track assets across the state on an interactive map. Easily filter data by district, tehsil, department, and date range. Clicking on an asset reveals detailed information such as asset ID, change area, and percentage. Use the swipe feature to compare layers side by side and view changes over time. This tool simplifies asset management, providing clear insights for better decision making.
Okay, so now taking it further, this is the implementation approach. Actually, it tells you step by step how we implemented this solution. So we started with a solution for asset collection, or you can say data collection, and the tool used was the mobile app. After that, the satellite data procured is captured and into subjected to the change detection. Once the change detection happens, there are alerts, and alerts are validated further using various workflows. Once it is validated and verified on the ground with geotagged photos and videos and approved, then there are various presentation methodologies like map application, dashboard, interactive visualization, etc., that presents the curated information in a simple and actionable information kind format to the intended recipients. This is the implementation extent, just to give you an idea of how a large scale implementation this is. So you can see the yellow highlighted areas are high transaction value areas, and green shaded areas are low transaction value areas. And this is used to demarcate the impact of the encroachment. So the cost of encroachment decides which area is high priority and which area is low priority. So the assets cover around 40,000 square kilometer of area here for this implementation. And the top that you are seeing for Uttarakhand is snow covered area, which is excluded from this solution. Around 70,000 assets have been captured till now into the system. This is the technology stack that entails this solution. You can see we have ArcGIS Enterprise, Esri ArcGIS Enterprise, ArcGIS Runtime, and various technologies like Python and JavaScript for enriching the application. Now coming to the main components and their first look. So you can see there is a bilingual mobile app. There are information disseminators like dashboards and MIS reports. And then there is the key, the component, which is web-based map application. Now coming to how these all components interact with each other. So as I mentioned, we start from the legacy source of truth, which is the public asset management portal for Uttarakhand, where all the information, which is attributes captured for all the assets of government, were there when we started initially. This is a repository of all the assets for their attribute information. We took that information into the mobile application for creating polygons. So the department officers and their team created these polygons on the ground, and these polygons were subjected as area of interest for the further processing. All of this is captured into a geo database, and then we have the ArcGIS desktop or ArcPro enabled models where the change detection training has been done on the data sets provided, and also these act as the trigger for the web application to do the change detection. Once for a subjected area the changes are detected, those are floated into the WebGIS component, where the alert notifications are analyzed using various methodologies and tools provided by the nodal agency USAC. And then once the genuine alerts are identified, they flow back into the mobile application. And this login based mobile application provides role based access to the users. So you can only see the slice and dice of data which you are meant to. Once mobile application is used for verification and validation and approval happens on that data, it comes back to the geo database from where it is disseminated using various graphical and tabular reports and dashboards. So this comprises of the solution and the interaction between them. Going further, I am about to show you the feature extraction outputs for built up area in this project. And these outcomes are from the deep learning package, which is trained by Esri India on the data exclusively provided by USAC. So you can see very high accuracy has been observed after multiple rounds of training of data. And we have extensively trained this model on various terrains. So there are riverbeds, there are hilly regions, there are plains, urban and rural areas. So my colleague Saranya has already enlightened on this topic, so I will not take much of the time. Going ahead, this is the crux of the solution, where you can see two set of temporal imageries subjected as source and target imageries, and our AI engine extracts the change which is identified. You can see there are buildings cropped up. Alongside, you can see there is vegetation change also, but since the model is trained for built up area detection, built up change detection, it is identifying and highlighting red colored changes only. And this is the part of the report that I was showing. This is a dossier annexure which shows you for this particular asset, what are the numbers. So for example, what is the source data saying in terms of area? What is our mobile application saying? What is the change calculated from the source imagery and the target imagery, and overall change percentage? This data is further informed or enriched using encroachment information captured live from the field, and you can see some sample photographs also in the bottom. This report is submitted to the highest administrative offices after every cycle of change detection. That is the mandate of this government order. Now, since this is a resource intensive application and it requires a lot of capacity in terms of infrastructure, I would request my colleague Vedika to take you through the infrastructural requirements and how Esri India facilitates the same. Over to you, Vedika. Thank you.
Thank you, sir. So, as we have already got to know what GeoAI is and its benefits through our previous speakers, let's now understand where this whole solution will be running. So, GeoAI is computationally intensive application which requires high computation and thrives on large and complex spatial data sets with strong processing power and storage. Now the question is, where should this be running? So this system should be running in a place which is highly available, scalable, reliable, and secure. And in today's world, cloud are the place for it. Now this thing wouldn't have been much possible if they were on their on-premises. So to support this need, cloud platforms like AWS, Azure, and Google Cloud come into play, offering GPU computing power, ample storage, and scalable infrastructure, which is required to handle massive geospatial datasets and run AI models efficiently. Now, all our supported clouds are also MITRE impaneled, ensuring compliance with the government security standards. As in the previous, we have seen AI and ML-powered change detection and satellite image analysis requires high-performance infrastructure, such as GPU-enabled machines and vast storage capacity. Satellite images, especially when collected over time or in high resolution, consume huge amounts of space. Now, over here, cloud technologies play a vital role in GeoAI by providing scalable, secure, and cost-effective storage, making it easier to manage and process large volumes of geospatial data without investing in any kind of physical hardware or any additional IT staff. They also offer various tools and services that makes it easier to deploy AI models and manage geospatial datasets effectively. Now, using cloud for GeoAI has three main key benefits. First is the scalability. You can easily increase or decrease the resources based on your data load. Second comes the real-time processing, which means faster analysis leads to the quicker decision. And lastly, we have the integration, which means that the cloud services allow us to connect geospatial data with other big data sources smoothly. So cloud technology plays a vital role in making GeoAI powerful, flexible, and efficient. Now, do you think that only having the cloud will share your purpose? Well, I don't think so. Esri India has a dedicated team of cloud experts who not only will support your cloud journey, but also ensure it runs smoothly and securely. They provide a wide range of essential services to help you get the most of your cloud and GIS infrastructure. Now let's show you the various kind of services which we provide. We have the infrastructure management, application and data management, security compliances, and monitoring and support, and our SLAs. So starting from the infrastructure management, like we provide the users with the proper infrastructure so that the users can handle this software at ease. They don't need to worry about their servers, updates, or networking because we handle it all. We also manage the underlying VMs and the OS patching too. Now coming to the security compliances, where the security of your data is a priority. Even when we provide the cloud services to the users, we also provide them with the VAPT, which is vulnerability assessment and penetration testing via the third-party vendors. So if any users is having any issues or vulnerabilities, then Esri India is there to solve that. We also provide the users with the antivirus and integrated support on the same solutions, which is the security information and event management. Esri is also supported with the ISO 27001. Even coming to the monitoring and support, we provide the users with a 24/7 monitoring through our Esri native solution, that is the ArcGIS monitor. Along with the ArcGIS monitor, we have other cloud native technologies too. And we have decent SLAs, which are based on the business continuity and the business criticalities as well. Now coming to various cloud providers, which we have Esri already support, and we have been continuously serving our customers in the past as well as in the present too. So we support major cloud providers that are widely trusted, such as over here we can see the Amazon Web Services, Microsoft Azure, GCP, that is the Google Cloud Platform. Along with that, we also support the other cloud providers too, such as the Oracle Cloud Interface and the GeoAI. Now, coming to the various components of which we offer. So over here at the high level, we can see the 24/7 monitoring, end-to-end application support will be there for you. Then coming to the complete solution will be based upon the security compliances, which I already spoke before. You will also get a proper dedicated help desk support. The system will also be designed as per the Esri's security best practices. And if required, the solution will be designed with high availability as well as a disaster recovery setup to ensure continuity during the unexpected events. Now let's talk about a few more like this, such as we can see the auto-scaling and high availability. As in the previous, we have seen that GeoAI requires an auto-scalable and highly available system. Hence, that will be provided to the user as well. Then coming to the performance tuning, we also optimize the system performance and ensure that the application is operating smoothly without any latency or downtime. Now coming to the backup and recovery, there will also be a proper backup and recovery mechanism to provide you with a reliable safety net for your data, ensuring that your information always remains safe and secured. Now, apart from this, we have regular activities as well, such as the OS and application patching. The solution, as I said, will also be monitored 24/7 using the Esri India's native technology, that is ArcGIS monitor, as well as the other cloud native technologies, as well as you will also get the software upgrades whenever it is available. Now that we have gone through all the various components which we offer is at a flexible range of options depending on specific needs. Now let's move on to what value do we offer. So our team comprises Esri certified as well as cloud certified professionals. Our solutions are also designed to scale easily so that they can handle growing workloads or adapt to changing business needs without any disruption. We proactively monitor and maintain the system to ensure high performance, minimal downtime, and reliable operation. We also follow a strong security best practices and compliance standards to protect your data and meet regulatory requirements. Also, our support system is available around the clock to ensure the continuous service and quick resolution of any issues. We also ensure fully automated backups at both infrastructure and application levels. And by managing your GIS infrastructure, we help free up your internal teams so they can focus more on core business and innovations. Now, with this, we aim to support initiatives like the one which we have showcased today, where advanced technology and reliable cloud management come together to drive real change on the ground. So we have seen the advantage of the entire solution in the cloud, where we are there to support you. Thank you.